Okay. So, and this just falls in line, guys, with our properties of exponents that you know from days of when. Remember, if I have 2 to the third power is equal to 8, that in log form is log base 2 of 8 equals 3, right? So when I'm trying to figure out what these are, one of the ways that it makes it easier is when I just try to rewrite them in the form that it's not. 13 is written in log form. So I'm going to turn
Hey,
around.
we can't hear you.
No here? Uh-oh. All right, let's see. I don't know why that goes on sometimes. All right, good?
Yes, ma'am.
Okay, so I'm going to take this and write it in exponential form. I always set it equal to x so that I see that exponent. So I'm going to say log base, I'm going to say 7 to the x, that's this 7 to the x is equal to 7 to the 29, right? And that gives us that x is equal to 29. We have a property. We know that if we have a of a is equal to x, these two are the same. The only exponent in the world that could leave them the same is a 1. So using our properties, what it gives me is if I have this exponent up here, that's going to be my solution every time. On 14, I have log base 2 of 2 to the negative 13. Well, those 2's are the same. So that means that the exponent would be a 1. The whole solution is negative 13. 15, the whole solution is negative 4. 16, the whole solution is the square root of 2. When you have these that are the same, and I guess I should have written that out. On 15, I have that ln e to the negative 4. Well, remember when it's not down there, the natural log does have a base e. So you have the same thing. And that ends up with equal to a negative 4. On 17, even though it has that log in it, that log, that is an exponent, and 17 is in exponential form. So I'm going to take 9 to the log base 9 of 13, and I'm going to write it as a logarithm. So I'm going to say log base 9 of x is equal to log base 9 of 13. Those log 9's cancel each other out, and I get left with x is equal to 13. Giving me out a couple of these properties. They're going to allow you to break equations in 6-6 down and solve. On 6-5, when you're using these properties, guys, it's not a matter of trying to figure out what you should do, but looking at your problems and say, what can I do? Now, you know when you had a to the third times a to the fourth, you used your product property and you added those exponents and you got a to the seventh. Well, that is right here. I can have a multiplication and break it down into addition. I can have an addition and simplify it to a multiplication. I have the quotient property right here. I can have division and break it down into two subtractions, or I can have a subtraction and simplify it down into one division. So when I have problems like 19, I have log 8 of 2 plus log 8 of 4. Because my bases are the same, I can rewrite that. I can use my property here, my product property, and I can say log base 8 of 2 times 4. 2 times 4 is giving me an 8, so I'm going to say log base 8 of 8. And what is my exact value when these two are the same? That's going to be a 1. Okay? Problem 20. Let's see what you can work out on problem 20. 6 of 9 plus log base 6 of 4. You should get a single rational answer on that. Because of that plus sign, I'm going to use my property and I'm going to rewrite it as a multiplication. 9 times 4. 6 of 36. Now here's where you got to that point where it's not what am I supposed to do, but what can I do? What can I rewrite there? Do my numbers have any kind of relationship? Well, that 36 I could write to 6 to the second power, right? So then I go back up to here. And that means the whole thing is equal to 2. Okay? We good on these? All right, same business. We're going to break these down using our properties. into expressions with plus and minus. See if I can pull out any exact numbers. 37. I have log base 6 of 36 times x. So this time we have m times n, and I'm going to break it into two expressions. 36 plus log base 6 of x. Now we already know we've done this, so I have log base 6 of 6 to the second, which gives me 2. And if that was set up in an equation that I was trying to solve, getting rid of a bunch of that and just having a number 2 to eliminate makes the world a little bit easier place to be. When I have the quotient rule, like on 38, I'm not going to break it down into an addition problem. I'm going to break it down into a subtraction. So let's see what you would write. You can come up with breaking 38 down. Minus so far. What can I do with that 9? Three to the second power, which means that this whole part right here is just a 2. All right, then we're looking at our, where'd you go? Right here. Anytime I have an exponent on 39, y to the 6th. Now there's no relationship. If these were together, if these were the same number, this whole thing would 6 and I'm done, right? But they're not the same. So only thing that I can do to help me break this down is I put the 6 down in front. And I have 6 times log base 5 of y. And it's like, why? Why would you do that? What difference does it make whether it's in one spot or the other? But when we get into 6, and we're solving the equations, these things will come into play. So 40, 5, 7 of x. Not what can I or what am I doing or what do I need to do, but what can I do? How can I change these? How can I simplify? What can I do? All right, remember when you have something like ln of 5 or log of 5, and there is no base written here. When it comes to the ln, there's a given e there, and when it comes to the log, there's a 10 there. So right now for 41, I have the natural log of e times x, which would break down to the natural log of e plus the natural log of x. And you got to remember there's that given e down there, which lets me take this whole section and make it into a All right, and again, why? Why would you do? I know it doesn't make a whole lot of sense when we're just working with these properties, but when we get that equal sign in there, then these properties start to help us out some. Let's see what you can do with 46. Quotient, so I'm going to change it into a subtraction. 2 of a minus of b squared. Nothing really to simplify, but I can break that down to a 2 in front. 48. I have the natural log of x times, so I'm going to break that down into an addition problem. I have that radical there. How do I write the square root of 1 plus x squared with an exponent instead of the radical? The natural log of 1 plus x squared to the 1/2. Only one more thing I would present on this one. What else could I do? That exponent down front, right? So my final would be the natural log of x plus 1/2 times the natural log of 1 plus x squared. Okay, and that's just breaking them up and down. We're gonna, the next section on here is going backwards from where we're at. Instead of breaking them down, we're gonna take some that were broken down and we're gonna write them as a single logarithm. So for 57, I have 3 bases have to be the same. Just like any of these exponential properties we had from back when. If I don't have the same base, I'm dead in the water. There's nothing I can do. But that's going to come up to the u. So I have u to the third plus v to the fourth. Then 1 log base 5 u to the third times v to the fourth. Putting it back into 1. See what you can do with 58. How would you write 58? Mhm. I want to write log 3 one time. I want to write it more than once. So working on this property and this one. What do you think? Yes? Now again, not so much of what do I need to do as what can I do. What if I have 61? I'm going to write that log 4 one time. Then I've got x squared minus 1 in my numerator and x plus 1 to the 5th power in my denominator. There's something more I could do with that. Simplify. How can I simplify? No, an exponent doesn't distribute. When I have a plus sign or minus sign, an exponent doesn't distribute in. But I could simplify. Look at that numerator. What do you recognize? X squared minus 1. What do we call that? Isn't that the difference of squares? Couldn't I make that x plus 1 times x minus 1? Could I pull an x plus 1 out? Times x plus 1 to the 4th power. Now I can simplify one of those out, right? So my last would be log base 4, x minus 1 x plus 1 to the fourth power. See what you can come up with for 62. Because this is subtraction, I know it's going to be a quotient. And I have x squared plus 3x plus 2 in the numerator. And what do I have in the denominator? X plus 1 to the second power, right? Because that 2's got to come up. Now what can I do? Okay. And now it's going to be x plus 1 times x plus 2. And break that bottom back down to x plus 1. So my final is going to be x plus 2 over x plus 1. By the by, what's the base on this problem? When they don't write, when you have LOG and they don't write it in, you know it is a 10. LN is E, LOG is 10. So if I just gave you LOG of 10, what's the value of that? Right? Because that would be 10 of 10. And if they're the same, my value is a 1. All right, just a couple more. Now this is mostly an exercise in using our calculator. So if you have one. Talking about our change of base. So first of all, before we get into these problems, try punching in the log of -3. You should have a scientific, if you do sideways. And let's see, on my phone, I have to put the number in first. So I would put in -3 and then hit my log button. What did you get? when you hit -3 in your log button. Good. Okay? You can't take the natural log or the regular log of a negative number. Okay? This has always got to be positive, greater than 0. That's why when we were looking at which problems were x is greater than 3, because otherwise it would be a negative down there, and you cannot do the log of a negative number. Okay? Now, again, because we're talking about when I punch into the calculator and I hit log of 10, it's giving me a base 10. I can't do this problem. I can't punch in, make that 10 down here a 3. So I've got to use my change of base formula. And all that is doing is you're making it into a ratio. You're going to say log 21, and this will use your base 10, over log of 3. Now, sometimes you might have to use, again, this is just about using that calculator, parentheses. Some of you won't. So if I do log 21, and then I hit my division and do log of 3, I've got 5.808. Is that what you got on yours? I don't want you to figure out how to use your calculator on test night, right? Because sometimes you've got to hit buttons in different, depending on the calculator that you're using. All right, let's look at what do you get for log base 1/3 of 71. Bunch that in. And I'm going to cheat. $880. Did that come up? You're going to have 71 divided by of 1/3. And you're probably going to want to use the parentheses around your denominator after you get log 71. All I want to know is you can punch these into a calculator, because you're not going to figure these out in your head. There's not going to be any simplifying or calculating. You just got to know how to set it up and then how to punch it in. Okay? Try your 75. You should get 5.615. Um, two to the 1/2. Totally irrational numbers. All right. If you have questions or you want to work, I'm here. There's something from another section in 6. The rest of this class time is your time. If you're good, you're good.
What was the answer?
5.615.
One question.
Mhm.
Is that how you do 78? Like 1.5? Or,
2 to the 1/2. And you're gonna use like that cat button. It's gonna be 2 and that cat button and 1/2.
okay.
All right.
Is that what-
And that itself is irrational, so you're definitely gonna want parentheses.
Okay. Good, thank you.
Mhm.
So,
Mhm.
whenever we're trying to do when it has the log 5, like log 5 8 to 18,
Mhm.
you would divide it log 18 by log 5, which is always log 10.
Mhm. Log base 10. Mhm.
I was able to do it at home, but I can't remember my calculator back at my home.
I thought I had thrown a couple in the bag, but I didn't. I didn't even throw one in there for me.
You have a great day.
You too. You guys be safe.